Hi everyone, I am Pooja from SVC Computer Science Department. Today we are going to be talking about computer graphics and visualization. So the contents are 2D pipeline, 3D pipeline, RGB color model, CMY color model. So first we'll go through 2D pipeline. It is a session of a 2D scene that is selected for display is called a clipping window. Sometimes the clipping window is alluded to as the word window or the viewing window. Graphic pages allow us also to control the placement within the display window using another window called the viewport. So here is the clipping window, how it looks, and here is the viewport. This is world coordinates and this one is viewport coordinates. The clipping window selects what we want to see. Here is how clipping window looks like. It will just show us what we want to see. The viewport indicates where it is to be viewed on the output device. It has like x-axis and y-axis, and it shows the image according to their axis. So by changing the position of a viewport, we can view object at different position on the display area of an output device. Usually clipping windows and viewports are rectangles in standard position with the rectangle edges par- parallel to the coordinate axis. We first consider only rectangular viewport and clipping windows. I- It says that you cannot use any other shapes such as oval or circle for clipping windows and viewports. It is generally a standard position is rectangles. The world coordinate scene has been constructed. We could set up the separate 2D viewing coordinate reference frame for specifying the clipping window to make the viewing process independent of the requirements of any output device. Graphics system convert object description to normalized coordinate and apply the clipping routines. Systems use normalized coordinate in the range from 0 to 1, not more than that, and others use the normalized range from -1 to 0. So here we can see that some normalized coordinates are positive and some normalized range are negative. So at the final step of the viewing transformation, the contents of the viewport are transferred to position within the display window. Clipping is usually performed in normalized coordinates. This allows us to reduce computations by first concatenating the various transformation matrices. So here is how 2D pipeline looks like. So meshing coordinate is a construct world coordinate scene using modeling coordinate transformation, and then it converts world coordinate to viewing coordinate, and next step it converts transform viewing coordinate to normalized coordinate, and finally the map normalized coordinate to device coordinate, and it shows us the resulting output. So 3D pipeline. The figure below shows the general processing steps for creating and transforming a 3D scene to device coordinate. So construct previously we have studied about 2D pipeline where we can view object in two dimensional. In 3D pipeline we can view an object in three dimensional. First, construct the shape of individual objects in a scene within modeling coordinate and place the objects into appropriate position within this scene. World coordinate positions are converted to viewing coordinate. Convert the viewing coordinate description of the scene to coordinate positions on the projection plane. A two-dimensional clipping window corresponding to the selected camera lens is defined on the projection plane and 3D clipping region is established. This clipping region is called view volume. Um, this view volume was not previously there in 2D pipeline. It is a new concept to 3D pipeline. So here modeling transformation, then viewing transformation, then it goes to projection transformation, then normalized transformation and clipping, and finally the viewport transformation. RGB coloring model or RGB color model, where R indicates red and G indicates green and B indicates blue, and the combination of them can form a different color. So according to the Tristimus theory of vision, our eyes perceive color through the stimulation of three visual pigments in the cones of the retina. One of the pigment is most sensitive, that its wavelength is around 630 nanometer, that is red color, and another peak sensitive is about 530 nanometer, which is green color, and the third pigment is most receptive to light with a wavelength of about 450 nanometer, which is blue. So these three primary, red, green and blue, which is referred to as a RGB color model, we can represent this model using the unit cube defined on RGB axis as shown. So CMY color model. A subtractive color model can be formed with the three primary color cyan, magenta and yellow. A unit cube representation for the CMY model is illustrated. In the CMY model, the spatial position is 1, 1, 1, which is 1 in x-axis, 1 in y-axis and 1 in z-axis. It represents black because all components of the incident light are subtracted from each other. So the origin represents white light. Equal amount of each of the primary colors produce shades of gray along the main diagonal of the cube. A combination of cyan and magenta ink produces blue light because the red and green component of the incident light are absorbed. So this is a different model from RGB because there are different colors when compared to the previous model. So similarly, a combination of cyan and yellow ink produces green light, and a combination of magenta and yellow ink yields red light. So CMY color model is referred to as the CMYK model, where K is a black color parameter. So